Guys, so I keep having issues, so I'm going to do this taping by hand, so I hope it's not too wobbly. The density is different, or buoyancy is different. So it's the density of water. So a lot of people will make that mistake. A lot of people won't use the density of water. You need to use the density of water. And you also, thank you, I have my handy dandy assistant here. You also need to use the displaced volume. Okay, now the entire ball is underwater. So what do I mean by displaced volume? It's the volume underneath the water, if that's what you're looking at. So then the entire ball is underneath the water, so the entire volume is taken in place. But the cube isn't entirely in water, only a depth of d. And so his cross-sectional area, if you're looking down, that is still L squared. So that doesn't change, but it's now only to a depth d. And so that's another common mistake, is that people won't do that. And I just made a common mistake. I forgot gravity, so don't do that. Okay, so now if we go over, assistant, thank you. You get that? Okay, so now we're going to do a sum of forces in the water for both the styrofoam and the iron separately. And so we're going to do the buoyancy forces are going to be positive upward, all right? Tension is down for the styrofoam, up for the iron, and the weight for both of these is going down, okay? But we want to find R in terms of everything. And I haven't written down the final solution. It is posted online, so go online, look at it. I mostly wanted to emphasize the buoyancy, which is why I took this video. But what we want to do is that we want to get everything in terms of R. So when we plug in for everything, this is the equation we are going to get. Minus the t. So what we're going to do is we're going to add these two equations. The reason is that t is one of our unknowns. And so basically when we add these two equations together, we're analyzing the entire system together. So the other way we could have done this is just not decompose it, but kept it as an entire system. So by us adding it, it's the same thing as treating that as a system. And this would have a buoyancy force, both of these. This would have a mass, and this would have a mass. So we're just eliminating the tension by adding this too. And then what we do is once we add these two, we get this equation. It looks a little messy, but we're going to factor out the R, and then we solve everything in terms of R. And I forgot the gravity again. Don't do that. I did that on a test once, actually. My first year here, I forgot gravity, and I got some points off. It wasn't a big deal. But don't do it, you know? Learn from me. Okay. Thanks, guys.